Okay, I'm making this video to go along with one of the example problems from the learning module because I feel like it's, it kind of comes out of nowhere. It says use the direction field of this differential equation. I've changed the equation, but this one is about similar difficulty to sketch some solution curves. And the direction field is not given. So you have a couple of options here. Either you draw a direction field yourself on a piece of paper or you reach for a piece of software. So I would recommend that you Google either direction field, or you may have more luck with the term slope field. I did. And I found that I was able to use GeoGebra to create the slope field for this differential equation. And this is fantastic because it gives me a really strong visual for sketching some solution curves. So for example, I'm seeing that all of the tangent lines up here in quadrant 2, they kind of make like swoopies. So I'm thinking that the curves are going to kind of be like swoopy. So here's one that I think kind of makes sense, that follows the tangent lines, right? You're just like following the flow of the little line segments. So I kind of feel like these are all individual solution curves to this differential equation. Secondly, I want to point out something that's unusual about this differential equation that I think is pretty cool. Did you notice how along here, these are all diagonal little line segments? Little tiny diagonal line segments. And so it kind of seems like this straight line might be a solution. Well, here's the cool thing, it is. This is the line y equals negative x minus 1. And when you plug it into the differential equation, you get y prime, which is negative 1, is equal to x plus negative x minus 1. And so that is, in fact, a solution, which is kind of cool. All of the rest are definitely swoopy and curvy. So now the instructions say sketch the solution curve that passes through 0, 0, and there is 0, 0 right in the center. Just to get a little bit of extra information, since there's not a line segment going through that point right now, I am actually going to figure out what y prime at 0, 0 is equal to. And so y prime is going to be 0 plus 0 is 0. And that means that the tangent line right at this point is supposed to be horizontal. So what I've done here is I've started a line going off to the side. And you notice how over in this area, all of the little line segments have positive slope. So I kind of started swooping this way. And then I noticed that the line segments were getting steeper and steeper. So I kept swooping steeper and steeper and steeper and steeper. So that's how I decided to make this gold curve the way that it is. Now, if I'm going backwards, this is supposed to be horizontal. And I'm looking in this little region right here. I'm noticing that all of the little line segments have negative slope, which means that this thing needs to bend upwards towards this blue line. And hey, by the way, pro tip, solution curves never ever intersect. They never intersect. And so we know if this diagonal line, by the way, is a solution, this gold curve will not cross the diagonal line. So what I'm going to do is I'm going to swoop upwards towards the blue diagonal line, and I'm going to make that shape. So there, I have finished the problem. I sketched the solution curve through 0, 0. So let's say you do not have software to help you with this. You could sit down with a pencil and paper, and you could make a giant table, and you could actually generate all of these little line segments yourself. You could make little tick, 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 tick all through the grid. And you can see how many little line segments there are in this computer-generated image, right? Doesn't that sound like the worst job in the world? So what we're actually going to do, now I noticed that in the exercise that you've been asked to do, it's multiple choice. It gives you several curves and says, find a solution curve passing through the point 0, 0. So I'm going to ask this a slightly different way. Let's say you grabbed one of the choices, that this was a choice in the multiple choice question. And we're asking ourselves, well, is this a solution or isn't it? I don't really have computer software handy. I don't feel like drawing an entire slope field by hand. I really just want to know if this curve is a solution to that differential equation. So what you're going to do is you're going to grab a point along the curve, and you're going to find the slope of the tangent line at that point, and you're just going to check. And for me, I check a lot of points because this is not a hard differential equation to do. I can find slopes all day long if I want to, but I'm not going to waste my time finding slopes out here. Who cares? The curve is not there. The curve is down here. And so I'm going to start I am going to start making a table, The first column is going to be a point, any point I want, and the second column is going to be y prime. Now, yes, you could take any point in the xy plane that you want. I'm only going to pick points that are on the curve because those are the ones that help me. 0, 0, the slope should be 0 according to the differential equation, and bam, it sure does look like it's horizontal there. How about that point? I like that point a lot. That kind of looks to me like 1, 0.7. Seems pretty reasonable. And that means that y prime is supposed to be 1.7. And does it look like here that the slope is 1.7? That's like over 1 box and up 1.7 boxes. I would say it looks pretty reasonable to me. Here's another point. To me, that looks like -1, positive 0.4. And so according to the formula, the slope is supposed to be minus 0.6, right? And so you take a look in here and you say, well, does this look like -0.6? That's over 1 box, down 0.6 boxes. And I'm saying, yeah, that looks pretty good. You do some more checks, right? Here's another point, 2, 4.4. The slope is supposed to be 6.4, really steep. And yeah, it looks really steep there. Finally, here's -2, 1.15. The slope is supposed to be -0.85. And yeah, it looks like, it looks steeper than the -0.6, right? Like it's getting closer to that diagonal. And that's because actually it's true. If you go way out here, the slopes are going to get really close to -1. Anyway, I'm feeling pretty convinced anymore that yeah, this curve seems legit. It seems like a solution to this DE, so I would have picked this as my choice.